Welcome back, geometry students. It's Mrs. Fallon again, and I am on page 88 of your student journal. But actually, before we get into that, there's a bunch of theorems in this last section. Actually, only two. I shouldn't say a bunch. There's only two theorems, but we're going to finish off kind of the two theorems that are left on our packet. So if you grab your theorem and postulate packet, let's go ahead and finish those two off. All right, so the last two are going to talk about slopes. And so this is definitely a more algebraic kind of concept, and you might already know this one. So hopefully you do, and then you don't have to worry about necessarily kind of committing this one to memory. The first theorem is slopes of parallel lines. And it says, in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slopes. So first of all, did you notice that was a biconditional? So if and only if. Which means that you can do it both ways. So the converse would be true as well. If two lines have the same slopes, then they would have to be parallel. And so what we're getting at here is that if we have, any two sets or any two lines that have the same slopes are going to be parallel. So parallel lines have the same slopes. All right, perpendicular. You probably know this one. And if you don't, here's a refresher. Slopes of perpendicular lines. In a coordinate plane, two non-vertical lines are perpendicular if and only if their product, if the product of their slopes is -1. So what they're talking about here is that if you multiply the two slopes together, they equal -1. And so that's an interesting way of thinking about it. I've always learned it where the slopes of perpendicular lines are reciprocals of each other, which is essentially the same thing, right? If you took a reciprocal of one, like 1/5, and you took, opposite reciprocal, and then the opposite reciprocal of 1/5 would be like -5/1, wouldn't you get this to equal -1? Yeah, you would. So anytime you multiply something by its opposite reciprocal, it's going to equal -1. So what I want you to remember with perpendicular lines is they have opposite reciprocal slopes. So make sure you get the whole opposite part. So opposite means opposite sign. So think if it was positive, it's now negative. If it was negative, it's now positive. So that's what they're referring to there. Reciprocal just literally means take the reciprocal of it. So you're like switching it around. All right, that does it for our theorem page here. So at least for this part, we can put that away for now. All right, let's talk about, I'm on page 88. So those were those theorems we're going to talk about. We're actually going to also talk about like a directed line segment, and that just means it's a distance, a specific distance where you're moving from one point to the next. So it's like it has a direction to it, like you're moving, up, down, left, right, north, south, east, west, something like that. All right, let's actually kind of move ahead to some of the extra practice that's on this page. So I'm on page 89. So these are kind of some of the problems you're going to be expected to do. It says, find the coordinates of point P along a directed line segment, AB, so that AP to PB is a given ratio. All right, so this one's a little bit complicated. And so I'm going to be honest with you, this gets a little bit confusing. So I want to make sure that we kind of go over these, and that if you need extra help, obviously don't hesitate to ask. So a directed line segment, again, is just kind of you're moving along a line segment. So you're moving along at a ratio of 3 to 1. So like if this were your line segment and you're moving along, that means if this is a ratio of 3 to 1, you've gone 3/4 and this is 1/4. So it's like you're kind of like partway through your destination. So you're talking about a ratio between like this segment and this segment. That's what they mean by a directed line segment. You're moving along that line segment. All right, so the first thing I want us to do is when we go ahead and find the rate, so using this ratio, and we're going to find the distance, so find the coordinates of the point. Actually, we're going to find the coordinates of the point along that directed line segment. So we're basically figuring out what coordinate points is this point going to be if we're moving along here at a ratio of 3 to 1. So the first thing I do is I find the slope of my line segment. So I'm going to do slope of A to B. So remember how to find slope. Slope formula is y2, so it's kind of important you get this right, y2 minus y1 over x2 minus x1. Watch all of your negative signs. So I have 1 minus 7 over -4 minus -2. So I get -6 over, if I change that, I get -2, which means I get a slope of 3. I'm actually going to leave it, and I forgot about this part, but I'm going to go ahead and leave it as just this ratio. So I'm not going to have you simplify that one down, and I'll show you in a minute why. The next thing I want us to do is I'm going to go ahead and sketch like a real quick graph of this. So if I had the point -2, 7, it would be somewhere up here, right? And then if I had the point -4, 1, it would be somewhere here. So what you're asked to do here is you're asked to find a point that's, if you're going from A to B, that it's at a ratio of 3 to 4. In other words, it's 3/4 of the distance along. So because this point is 3/4 the distance from point A, what we're going to do to get your x value of your new point, you're going to take 3/4. And again, how I figured out 3/4 is because it was 3 to 1. So it's 3 out of a total of 4. So it's 3/4 of my x coordinate of my slope. So remember, this is your change in y. This is your change in x. So the x coordinate of my slope, which basically refers to your, your run of your rise over run, is -2. And that's why I'm going to keep it like this. I want to keep it as a fraction. And so I get 3/4 times -2, and I get -3/2. For the y value, I'm going to multiply it by 3/4 as well. So the y value of my slope in this one, the rise part of my slope, is -6. So -6 times 3/4 is -9 over 2. So now what I'm going to do, this is the distance. So what I did is I calculated how far this point, we'll call it point P, how far point P has to be from A. It's going to be 3/4 the distance from A to B. So now what you're going to do is you're going to take those values and you're going to add it. So if this is the point, if A is at the point -2, 7, I'm going to add this distance to my x's and add this distance to my y's. So it's going to look like this. And I'm going to go in, I need a little bit more extra room here, so I'm just going to kind of write over here. So my point P is going to be, I'm going to take my x value, which in this case was -2, right? So I'm starting at A, going to B, so I'm going to start with my x value, and I'm going to add -3/2 to it. And the reason I'm doing this is so that I can figure out this distance. So I moved along that far. So I get -2 plus -3 over 2. So -2 plus -1.5 is -3.5. So that's my x value. And then for point P, I'm going to take the y value, and I'm going to add -9 over 2, or -4.5, however you want to word it. So I have 7 plus -4.5. And I get an answer of 2.5. And this would be my y value. So my coordinates of P would be -3.5, +2.5. And that would be the coordinates of P. So again, just as kind of a recap, I started out by figuring out the slope because I wanted to figure out the rise over the run. I wanted to figure out that distance from like A to B, to be honest with you. I wanted to figure out that distance from A to B, that rise over run. And then when I said, well, I only want P to be kind of 3/4 of that distance. So what I did is I took each of my y and my x, my rise and my run, and I multiplied it by 3/4, and then I added it to my original coordinates of my point A. And that's how I came up with point P. Let's do another one because I think these get a little confusing. All right, let's do part 2. And I'm going to write it on a separate sheet of paper because I ran out of room on this one. So number 2 says I have A at the point 3, 1, and B at the point 8, -2. And I want to use the ratio 2 to 3. All right, so if it helps you, go ahead and sketch a graph. 1, 2, 3, 1. So here's A. Let me move this up a little bit. And then 1, 2, 3, 4, 5, 6, 7, 8, -2. Here's B. And then you can use a straight edge if it's helpful, if it's handy. and connect them. All right, so I have my point. I graphed it. So the first thing, if you remember, I'm going to figure out the slope. So I'm going to do rise over run. So you can figure it out using the formula. You can figure it out from your graph. I don't really care. I'm going to use the formula just because it's easier for me. So I'm going to do the slope, and I'm just going to label this as slope of AB. And so I'm going to do y2 minus y1 over x2 minus x1. And so I get negative 3 over 5. All right, so again, you don't have to simplify, obviously this one can't be simplified, so don't change into a decimal or anything like that. All right, so now take a look at your ratio. We want so we're moving from A to B. I want to have point P at a ratio of 2 to 5. So it needs to be 2 out of 3. So it's a ratio of 2 to 3, which means it needs to be, like if you divided this into 5 equal segments, and didn't really do that correctly, but if you divide this into 5 equal segments, it needs to be at a distance of 2 segments and then a distance of 3. So somewhere like around here. We want to have it 2/5 of the distance away from A to B. So what I'm going to do for x, my x value of point P, I'm going to take my 3/5 and I'm going to multiply it by my x value, or my run of my slope. So 2/5 times 5, I'm sorry, 3/5 times 5, is that 3? I'm sorry, it should be 2. So 2/5, because it was 2/5 times 5, gives me 2. And then for the y value, I'm going to do 2/5 times my run, which was my rise, which was 2/5 times negative 3, and I get negative 6/5, which is like negative 1 1/5. So now my point P, I am going to add that to my, so for point P, I'm going to go ahead and do this part first. I'm going to take point A, which was at the coordinates 3, 1, and now I'm going to add 2 to the x value, and I'm going to add, or subtract kind of, negative 6/5 to the y value. So to get to point P, 3 plus 2 is 5, and 1 minus 1 1/5 is 1/5, or negative 1/5, which is negative 0.2. So that would be the coordinate of point P. So the steps are: find the slope of your original line segment, and then leave it as like rise over run. So again, this is your y, this is your x, and then take your ratio and multiply each of your x and your y by that value, and then add that to your starting point, which in this case was point A. So add it to your x value, add the y value, and then you get your coordinates of point P. Definitely a little bit more challenging, a lot more steps involved in there, so I encourage you to practice that one a few different times. All right, number 3, it says determine which of the lines are parallel and which of the lines are perpendicular. On this one, what I would do is I would figure out the slopes of all of these. So this kind of takes a little bit of time, but what you want to first figure out is, like, you have P and Q. Those ones kind of look parallel, so what you want to do is figure out the slopes of P and Q. So what I did is I just calculated the rise and the run. So I'm going to use pencil here because I'm going to have to erase some of this. So I'm going to do, you can do the slope formula if you want and just find the slope of line P. So you can pick any 2 points and use the formula. I'm going to use rise over run. So I get 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I get the slope of P to equal 1. And then I'm going to do the slope of Q. And I get 1, 2, 3, 4, 5 as my rise, 1, 2, 3, 4, 5 as my run. So the slope of Q is 1 as well. Now I'm going to find the slopes of all the other lines. So for line R, and again, all you really need is 2 points to figure out the slope if you're going to do like rise over run. Notice that it's decreasing, so my rise is actually, we're decreasing 1, 2, 3, and my run is 1, 2, 3, 4. So for slope of R, it would be negative 3 over 4. For S, again, just pick 2 points. So I guess I'll pick this one and this one. So it's going to be negative because we're going to go down. So 1, 2, 3, and 1, 2, 3. So down 3 and over 3 means my slope is -1. And then the slope of line T, which is the last one, which is here, I'm going to pick this point and this point. So I'm going to go down 1, 2, 3 and over 1, 2, 3, 4. So down 3 over 4 is -3/4 as a slope. So the first strategy I did for this one was just to figure out all the slopes. Now you can start naming anything that's parallel, perpendicular. Any lines that have the same slopes are parallel. So I would say P is parallel to Q because they have the same slope. R and T have the same slope. So those are parallel. Any slopes have opposite reciprocals. So like -1 and 1 are opposite reciprocals. So P is perpendicular to S, but so is Q is perpendicular to S. And that was that one theorem we talked about. If two parallel lines are perpendicular to the same line, then they're perpendicular to each other. All right, so those are kind of so that was kind of my strategy on this one, was just to figure out all the slopes and then take a look. And I knew that parallel slopes were equal and perpendicular slopes were opposite reciprocals. Let's do some. Tell whether the lines of the given points are parallel, perpendicular, or neither. So the easiest way to do this is to figure out the slopes of all of these. So you can plot them and do it that way. I'm going to go ahead and just use the formula this time. So I'm going to do the slope of line 1. So I'm going to do y2 minus y1. And again, I can't stress that enough. And x2 minus x1. So I get 2 over -4. If I reduced it, I would get -1/2. All right, let's do the slope of line 2. I'm going to do the same formula, y2 minus y1, and x2 minus x1. I get 6 over 3, which I get 2. So how are these related? Are they the same? No. So then obviously lines L and or line 1 and 2 are not parallel. Are they opposite reciprocals? Yes. So you would say line 1 is perpendicular to line 2. Because they have opposite reciprocal slopes. One's positive, one's negative, and then they're reciprocals of each other. All right, let's have some more fun. We're on the next page, so page 90. 3 more problems. All right, so this one says, write an equation of a line passing through a point that is parallel to this other one, and then graph the equations of the lines to check that they're parallel. All right. So you probably did this in Algebra 1. If you don't remember how to do it, then this is kind of your refresher. So anytime I'm asked to write the equation of a line, and I'm given a point, and I'm talking about slopes, I'm going to use the point slope form. This is what we call our point slope form. Y minus y1 equals x, m times x minus x1. So the first thing I'm going to do is, if I'm going to write an equation of a line passing through this point. So I'm going to go ahead and graph this. So I'm going to draw in my axes. And then 1, 2, 3, 1, 2. That's point P. And then this one has a y-intercept of -1. And then a slope of 2, which means I go up 2 to the right 3. And then I can go down 2 to the left 3. So this is my line, this is my other line. So I'm trying to figure out a line parallel to my original line, but passes through point P. So if they're parallel, then they have to have the same slopes. So my M needs to be 2/3. So that's one of the things that I have to identify. The next thing is in order to find my, like the rest of my equation, I'm going to plug in this point. So I'm going to plug in P, which is 3, -2, in for y1 and y2. So this becomes x plus 2 because it's y minus a -2. And this one becomes x minus 3. All right, I want you to write your equation in slope-intercept form, which means I want you to solve for y. So let's distribute. Well, I should probably do that first. Let's distribute. And then let's go ahead and subtract 2 from both sides. So why they're having you graph it is just to make sure it makes sense. So 1, 2, 3, 4. -4 is my x, or my y-intercept. My slope is up 2 over 3. Did I get my point? I did. So now I have a line parallel to my other line, and it passes through that point. All right, now let's do this one. Write the equation of a line passing through a point that is perpendicular to this other one. All right, I'm going to go ahead and start by graphing this one again. So -2 is p. This line has a y-intercept of +3 and a slope of +2. So up 2 over 1, down 2 over 1. All right, so this is my line, not very straight, but that's okay. All right, so we're going to make a perpendicular line from P to the line. Okay, again, I'm going to start with the point slope formula. And I'm going to plug in my point, but I'm also going to plug in a slope. Well, what we know about slope perpendicular lines is that they're opposite reciprocals. So the opposite reciprocal of 2 is 1/2. And so when I plug in my y value and my x value into x1 and y1, I get that. Again, I want you to write this in slope-intercept form. So I'm going to go ahead and distribute, and now I'm going to add 2 to both sides. So this should be the equation of my line. Let's make sure it does actually kind of look perpendicular. So it means I have a y-intercept of 1 and a slope of down 1 over 2, or up 1 to the left 2. Yep, it works. So that would be my perpendicular line, and that's how you can kind of check your work. All right, last one, number 7. So on this one, it says find the distance from a point to a line. Again, kind of recommend, I always kind of sketch a graph at the very least. You do it on graph paper. What I'm doing is just kind of sketching it this way. So that this is my line, and 0, 5 is up here. So I know I'm going to have a line like this, because I need the distance from this point to this line, and I need this to be perpendicular. So what we're actually doing here is we're kind of making a combo. We're kind of doing a little bit of what we've been doing right now with the algebra, just kind of putting it all into one problem. So here's what I mean by that, is you need to figure out this perpendicular line. Like you need to figure out the distance from here to here, but you need this to be perpendicular to that one. So the first thing I'm going to do is I am going to go ahead and figure out that I'm going to find the equation of the line that passes through P. So I'm going to go ahead and do I'm going to find the perpendicular equation from point P to the line. So what I'm going to do first is I'm going to go ahead and look at the slope of this line here, because we have this equation. So the perpendicular slope, so in other words, the opposite reciprocal, would be 1/3. Which means that if it has to pass through this point and have this slope, my equation will be 1/3 x plus 5. So my first step, and I'm just going to write down steps because I think it'll be easier for you guys. I'm going to find the perpendicular equation from the point to the line. So again, I just took the slope, so I took the opposite reciprocal, and then I used this point to help me figure out the equation. And that happened to be my y-intercept, so I just plugged it into my general equation. If it wasn't the y-intercept, then you would use the point slope formula like we did above. All right, step 2. I want to figure out this point right here. I need to figure out where this line and this line intersect. And the reason why is because I need to know what this point is so that I can figure out this distance. So step 2 is actually solving a system. So I know this equation, I know this equation. Where they both intersect is called a solution to a system. So I'm going to take my two equations and I'm going to set them equal to each other. So negative 3x minus 7 has to equal 1/3 x plus 5. So this is using that substitution property that you talked about so much in Algebra 1. I'm going to solve this system. So I am going to get, if I subtract 1/3 from both sides, I get negative 10/3 x. And then if I add 5, I get 10. And then if I multiply both sides by -3/10, I get -3. So I get an x value of -3. Again, we're solving a system. So I get -3 as my x value. Let's find the y value. So pick one of your equations. So I'll do the one that was provided to me. I'm going to plug in -3 in for x. And I get 4. All right, so now I figured out that this point right here is the point -3, 4. And I know point P that we did, actually it's point A, but that's okay, call it A, is the point 0, 5. So now I have those 2 points. Now I need to find the distance between them. So step 3 is find the distance from A to, I don't know, we'll call it X. A to X. So let's find the distance formula. I'm running out of room here, so I'm going to have to grab another sheet of paper. So point A was at the point 0, 5. Point X, I called it, is at the point -3, 4. So I'm going to find the distance between those 2 points. So I'm going to do x2 minus x1 squared plus y2 minus y1 squared. And I'm going to get 9 plus 1, which is root 10. So we did 3 different kind of major math steps here. So find the distance from point A to the line. This would be your final answer. This is your distance from the point to the line. So again, the first thing we did was wrote an equation of, basically we wrote an equation of this line segment here. So we took the perpendicular slope from this one because we knew it had to be perpendicular. And then this was the y-intercept, so I plugged it in and got this equation. The second part, I solved the system. So I took this equation here and the one that I originally had, so the 2 lines, and I set them equal to each other. So I just substituted in for y. And I solved for x, plugged it back in, solved for y, so I could get that point. This is the solution to the system right here. That's that point. Last but not least, I found the distance between those 2 points. You could use the distance formula, or if you wanted, you could use the Pythagorean theorem. Didn't really matter. Either way, you find an answer of root 10. I would strongly recommend that you practice these problems. All of these were relatively, some of this maybe was review, but it's definitely something that I would like you to review a couple times just because it tends to get a little tricky and there's multiple steps. Of course, if you have questions, watch the video again. That might be my first suggestion, but also come to your teacher, ask questions, be proactive. All right? All right. Bye, guys.